Imagine an empire built over millions of years, one that endured nature's harshest trials and overcame every single one of them. And then, suddenly, everything was destroyed. This is the story of the dinosaurs, the most extraordinary land animals ever to walk this planet, which over more than 160 million years evolved into countless forms and came to dominate virtually every environment on Earth. The extinction event itself is well known, but there are layers to this story, strange details, staggering improbabilities, and unsettling twists you've probably never heard before. And to truly understand it, it's time to go down the rabbit hole. By the end of the Cretaceous period, 66 million years ago, the continents already looked surprisingly similar to the ones we know today. And it wasn't just the dinosaurs that inspired awe with their sheer size. In the oceans, gigantic marine reptiles thrived in astonishing diversity. In the skies, the largest flying animals to have ever existed ruled the air, the pterosaurs. This was the age of reptiles at their absolute peak. Nearly every animal on Earth weighing more than 10 kilograms was a dinosaur. And then, it all ended. Although the extinction of the dinosaurs is now well established, up until the 1980s, the true cause remained uncertain. Other explanations had been proposed: disease, even massive volcanic activity. But then, evidence for a catastrophic impact began to emerge. In 1980, a landmark study revealed unusually high concentrations of iridium in rock layers, marking the end of the Cretaceous period, the boundary that marks the end of the Mesozoic era, the age of dinosaur dominance, and the beginning of the Cenozoic, the era of mammalian rise and diversification. Iridium is a heavy element that, during planetary formation, tends to sink toward the core, making it extremely rare in Earth's crust. But in meteors, that separation process never occurs, leaving them relatively rich in iridium. So, finding an abnormal concentration of it in rocks from this exact moment in Earth's history strongly suggested an extraterrestrial origin. Still, not everyone was convinced. Some argued the iridium could have come from deep within Earth itself, released through intense volcanic activity. But the evidence kept piling up. Shock quartz was discovered. Minerals formed only under unimaginable extremes of pressure and temperature, exactly the kind produced by a colossal impact. Tiny spherules revealed that molten rock had been blasted into the atmosphere, only to rain back down onto the planet. And then there was the soot layer, evidence of massive fires igniting after the event. All of this could not be coincidence. And it wasn't. But if an asteroid really caused the extinction of the dinosaurs, where was the crater? The concentration of shock quartz was highest around the region of present-day Mexico, strongly suggesting that the impact site lay somewhere nearby. And then it was found. Buried beneath the Yucatan Peninsula in the region of Chicxulub was a crater 180 kilometers across, a scar. The definitive proof that the extinction of the dinosaurs came from space. The object that struck Earth was a colossal rock, estimated to be around 10 to 12 kilometers wide. For scale, it was slightly larger than Mount Everest. Its mass was comparable to the largest mountain on Earth, roughly 1 to 3 quadrillion kilograms. Traveling at around 20 kilometers per second, it slammed into the planet with an estimated energy release of 100 million megatons, around 2 million times more powerful than the most destructive nuclear weapon ever built, the Tsar Bomba. The impact struck a shallow sea in a region where the crust was rich in carbonates and sulfates. At the moment of collision, the air compressed beneath the asteroid reached temperatures hotter than the surface of the sun. The crust itself liquefied, behaving like a fluid and generating colossal waves through the Earth. Moments later, the newly formed crater collapsed inward, dragging asteroid material deep into the planet, where it mixed with Earth's crust tens of kilometers below the surface. Any animals near the impact zone were instantly vaporized. Then came global earthquakes on an almost unimaginable scale. Mega tsunamis, some with waves reaching up to a kilometer high, swept across continents. Incandescent rock debris was blasted into the atmosphere and even beyond it. When that material fell back to Earth, it ignited global wildfires. But for the dinosaurs that survived the day of impact, the worst was still to come. Cold and darkness. In the aftermath of the impact, the skies filled with rock dust and soot from the global fires. This debris blocked sunlight for years, reflecting much of it back into space. If our planet had been viewed from orbit during that time, it would have appeared far brighter than usual. But at the surface, almost no sunlight remained. With so little solar energy reaching Earth, photosynthesis collapsed, devastating plant life both on land and in the oceans. Marine ecosystems began to unravel. The collapse of the food chain, combined with sulfur-driven ocean acidification, wiped out the ammonites, creatures that had survived on this planet for over 300 million years. The mosasaurs, extraordinary marine reptiles that were at the height of their dominance, were also completely exterminated. On land, the catastrophic loss of vegetation, combined with the brutal cold, led to the collapse of herbivorous dinosaur populations, and soon after, the carnivores that depended on them. It's possible that some populations of non-avian dinosaurs survived for a few more years in regions far from the impact site. Deserts, lacking dense forests, may have provided temporary refuge, allowing isolated populations to persist for decades, perhaps even longer. Antarctica is another intriguing possibility. Dinosaurs there were already adapted to cold conditions and endured months of seasonal darkness each year. Some may have held on longer than their relatives elsewhere. But in the end, no viable ecosystem remained capable of sustaining them over the long term. And so, every non-avian dinosaur disappeared completely. Only one lineage survived, the birds. And yes, they are dinosaurs. In the years following the impact, the planet became a world of decay. Massive amounts of dead organic matter, weak sunlight, and freezing temperatures created ideal conditions for fungi to spread. And strangely enough, that may have helped seal the dinosaurs' final fate. Mammals, with their consistently higher body temperatures, are naturally more resistant to many fungal infections. But many dinosaur species were likely not fully homeothermic in the same way mammals are, potentially making them far more vulnerable to fungal disease in this devastated post-impact world. With the dinosaurs gone, mammals suddenly found countless ecological niches left vacant. And what followed was an evolutionary explosion. A diversification that, millions of years later, would eventually lead to us. A cataclysm of this magnitude forces us to ask, where did this asteroid come from? In 1984, a paper proposed a darker possibility. What if the Sun had a sibling, a distant companion star orbiting in an enormous, elongated path? One that every 29 million years drifted dangerously close to the solar system. This hypothetical star was called Nemesis, a faint object, possibly a red dwarf or even a brown dwarf, that as it passed nearby would gravitationally disturb asteroid orbits, hurling them toward the inner solar system. It's a chilling idea, but Nemesis was never found. And today, that hypothesis is no longer considered likely. A far more plausible origin lies between the orbits of Mars and Jupiter, the asteroid belt. This is where the dinosaurs' executioner most likely began its journey. Over millions of years, sunlight may have slowly altered the asteroid's orbit through something called the Yarkovsky effect. As sunlight heated the asteroid's exposed surface, it re-emitted that energy as infrared radiation, producing an almost imperceptible thrust, a tiny acceleration, but one that compounds over immense spans of time. Little by little, its orbit shifted. Then Jupiter entered the story. The giant planet's immense gravity accelerated the asteroid, effectively slingshotting it toward the inner solar system. And by catastrophic misfortune, Earth was in the way. Probably not directly at first, but Earth's gravity may have pulled it into a final collision course. On a cosmic scale, the odds of this happening are absurdly small. Space is overwhelmingly empty. The extinction of the dinosaurs was the product of something profoundly improbable. But the improbability goes even deeper, because the location of the impact changed everything. The asteroid struck a region where Earth's crust was rich in carbonate and sulfur-bearing rocks. That detail may have determined the fate of life on Earth. Had the collision happened in the deep ocean or over basalt-rich crust, the amount of dust and climate-altering material blasted into the atmosphere would have been dramatically lower. The prolonged impact, winter may never have happened, and neither would the cascading extinction that followed, which means this may have come down to mere seconds. Just a few seconds difference in timing could have directly altered the entire biological evolution of life on Earth, including the emergence of humans. A few seconds, and we might not be here at all. A true cosmic and geological butterfly effect. A 2019 study may have uncovered something extraordinary. Fossils from the very day the asteroid struck. At a site called Tanis in North Dakota, researchers discovered a remarkable fossil deposit that appears to preserve the immediate aftermath of the impact itself. A massive number of animals were found buried together in the same location, suggesting they were overwhelmed by a tsunami that surged deep into the continent. Among them was a turtle impaled by a tree branch, evidence of an event of almost unimaginable violence. But the most astonishing clue came from the fish. Tiny glass spherules were found lodged in their gills, fragments of molten rock from the impact, which means these fish died on the exact day of the collision. And by analyzing the growth patterns in their skeletons, researchers concluded something haunting. It was spring in the northern hemisphere, and that was the last spring of the dinosaurs.